Today we will solve a few more problem sums based on ratio and proportion, which are of level 3. So let's get started. The first one says the ages of Ram and Lakshman are in the ratio of 4:3 and the sum of their ages is 49 years. Then find the ratio of their ages after 7 years. So their current ages are in the ratio 4:3 and their total age, the sum of their ages is given, which is 49. So what will be the present age of Ram? It will be the age of Ram, it is in the ratio 4:3 with Lakshman. So it will be 4 divided by 4 plus 3 and then multiplied by total age. So it will be 4 by 7, 4 out of 7, and then out of 49 what it will be? It will be 7 sevens are 49, so it will be 28 years. Then for Lakshman the present age will be in the ratio, it is 3, and then it will be out of 7, and then the total age is 49. So out of that, how much will be the age in the form of years? So it will be again 7 and it will be 21 years. So 28 and 21, it gives us 49 years. Now after 7 years, Ram's age will be what? 28 plus 7. So it will be 35 years. And for Lakshman, the age after 7 years will be, current age is 21. So it will be 21 plus 7, 28 years, right? And what we need to find the ratio of their ages after 7 years. So their ages after 7 years are 35 years and 28 years. So it will be 35 is to 28. And in case of 35 and 28, the common factor is 7. So the ratio, thus in the simplest form, it will be 5:4. Now in the next sum, what we need to do is, a bag contains rupees 750 in form of 1 rupee coin, 50 paisa coin, and 25 paisa coins in the ratio 5:8:4. Then find the number of coins of each type. So in our bag we have different types of coins like 1 rupee coin, 50 paisa coin, 25 paisa coin, and the total valuation of all those coins is rupees 750. Now the number of coins are in the ratio 5:8:4, but their total valuation is 750. So we need to be a little bit careful when we will find the number of coins for each type. Now here bag contains rupees 750 in total, that is the total valuation, and their ratio is 5:8:4, but this ratio is of their number, the number of coins. Now we know that in case of 50 paise coin, we need two such coins for 1 rupee, and in case of 25 paise coins, we need four such coins for 1 rupee. So from the total valuation, which is rupees 750, if we want to find that how much each coin contributes, then first we need to find the ratio of their valuation. Now in case of 1 rupee coin, since one coin contributes to 1 rupee, so it's 5, it's okay. But in case of 50 paise coin, two such coins contribute to 1 rupee. So in terms of number of coins which is given, that ratio will be half, because 150 paise coin valuation, that valuation is half rupees. So it will be 8/2, so that will be 4. And 125 paise coin in terms of rupees, that value is 1/4 rupees, right? So in the ratio, it will be 4 divided by 4, and that will be 1. So in terms of valuation, and that is in rupees, if we think, then their ratio will be 5:4:1, and 5:8:4, it is in terms of their number. So now, since from the total rupees we will find their numbers, so in case of 1 rupee coins, the total number will be, it is 5, and the sum of this ratio is how much? It is 10. So out of 10 it is 5, and the total valuation is 750. So now 10, so it will be 75 multiplied by 5, so it will be 375. and since we are finding the number of coins, so it will be 375 in number for 1 rupee coin. Now for 50 paise coins, the ratio we have 4 and the total value is 10. So out of 10 it is 4, and then that will be multiplied by total rupees, that total valuation 750, and this 0 0 will cancel each other. Basically 750 is divided by 10. Now this is in rupees, but what we are finding, we are finding the number of coins. So number of coins of 50 paise. Now this is the total valuation of 50 paise coins. So the total number of coins for 50 paise will be multiplied by 2, because 2 50 paise coins contributes to 1 rupee. So that will be 75 multiplied by 4, it is 300, and multiplied by 2, it will be 600. Now for 25 paise coins, the total number will be, first we will represent in terms of total valuation. So it will be 1, and then out of 10, and then multiplied by total valuation 750. So it will be 75 rupees. So in terms of rupees, its total contribution will be 75, but we are finding the number of coins. So for 1 rupee, the number of coins, number of 25 paise coins that we need is 4. So total number of 25 paise coins will be in that case 300. Now let's move on to the next one. It says that if a by b is equal to x by y is equal to p by q, then what will be the value of this given expression, where we have an algebraic expression in terms of axp in the numerator, and in the denominator also it is an algebraic expression in terms of byq. Now in that case, what we will do is we will assume that this ratio a and b, x and y and p by q, which are equal, and that will be equal to a constant value which is k. So if it is so, then we can say that a by b will be equal to k. So in that case, a will be equal to bk, and similarly x by y, that ratio will be also equal to k. So x will be yk, and in the same pattern p will be equal to qk. Now let's come to the expression where we have axp, means whatever we have in the numerator in that ratio, all those variables we have in the numerator of that given expression, and whatever we have in the denominator, that also given in the denominator of that expression. So what we can do is, either we can represent axp in terms of byq, or we can represent byq in terms of axp. And what we have already found here, that a in terms of b, and with that we have that proportionality constant, and x in terms of y, and p in terms of q. So in place of a, we can easily put the value bk, and then we have 9x. So 9, and in place of x we can write yk, and then we have 2p. So 2, and in place of p we can write qk. So in the numerator now, instead of a, x and p, we have the variables b, y and q. So we will keep the denominator whatever it was, so that expression will remain same. So 6b plus 9y plus 2q. Now if we simplify further, then k is the common factor in the numerator in all those three terms. So k will be taking as a common factor, and in the bracket we will have 6b plus 9y plus 2q, and in the denominator also we have 6b plus 9y plus 2q, and these two factors are same, so they will cancel each other, and what we will get as a final result is k. And what is k? K is equal to each of these ratio, a by b, x by y, and p by q. So the value of this given expression will be equal to each of this given ratio. That's what we can conclude. Now the next one. Here we need to arrange the ratio which are given in the form of 5 is to 6, 7 is to 10, 13 is to 15, and 23 is to 30 in ascending order. So what we can do is, first we can write 5 is to 6 means 5 by 6, and all other ratios also we have written in terms of fractions. And now rest is simple, as you know that what we need to do is we need to represent all these fractions into like fractions, and for that we need to take, or we need to find the LCM of all those denominator values. So between 6, 10, 15 and 30, if we take the LCM, that value will be 30. So 30 means, so here if we want to represent in terms of like terms, so here the denominator will be 30, and to do that the numerator will be changed to 25, and the rule we know. So 7 by 10 now will be changed to 21 by 30, 13 by 15 will be changed to 26 by 30, and 23 by 30 will be changed to 23 by 30, as the denominator is same as the LCM. So now if we look at the all these values, the revised or changed values, then here between all those values, four values, the denominator is same 30. So we can easily compare the numerator values, and then based on that we can conclude, or we can arrange in ascending order. And if we do so, then this will be the ascending order of all those ratio that was given. Now the next one and the last one. Here what is the statement? Mita takes 4 hours to travel from her place to her friend's place by bus. If she goes by car, whose speed is 2/3 times that of the bus, then how much time will she take to cover the same distance? Now we know the relation between speed, distance and time is speed is equal to distance divided by time. So we can also rearrange this way, that time is equal to distance by speed. Here the for the first case, when she traveled by bus, the time was given, the total time taken, and that was 4h. The speed was not given, but the relation between two speeds, when she traveled by bus and when she traveled by car, that relation is given, and one speed is 2/3 times of the other, and distance is same, that is also not given. So what we will do initially is we will assume that the distance is x. Now this is the relation. So in the first case, when she traveled by bus, time taken was 4 hours, and what we know, time is distance by speed. Now x is the distance that we assume between her place and her friend's place, and this is the speed. So in terms of that distance and time taken, what speed we have obtained here is x by 4. Now the relation is, when she traveled by car, that speed was 2/3 times of the speed when she traveled by bus. So when she traveled by car, the speed, we can say it will be 2/3 times of the speed when she traveled by bus, and that we obtained as x by 4. So the speed for car will be x by 6, and now the time taken when she traveled by car will be what then? Then the same formula, time is equal to distance by speed. So it will be distance is same as per the problem statement, and that is x, and time is distance by speed, speed is x by 6. So finally the time will be 6 hours. And since the speed is less than the previous speed, so the time that will be taken in the second case, that will be more than the previous time that was taken, because here what we can see is between time and speed the variation is inverse. So this much was for today's class. In the next class we will be solving a few more important and interesting problem sums. Till then, stay safe and stay healthy. Thank you.